proportional equation that changes. The number we are adding is called the b-value. The equations we worked with today are in the form y equals mx plus b.
So today we are going to be talking about what's different from last week where we just had our equations y equals mx. Those were proportional. We are now going to have this equation y equals mx plus b. We're going to talk about still where m is still going to be the what? Did we say Friday? M is our slope. Remembering that that is our rise over our run when we look at that. Please write this in your notes. And we're going to determine or define what is our initial value. Our rate of change is still going to be our m. The y-intercept is going to be our b. That's going to be the same as our initial value. So b will be the initial value. The rate of change, that's going to be our slope, our rise over run. And then our y-intercept is still the b. So it says we'll be using the graphing calculator, again, the online one, to make this work very quickly. But before we do that, before I have you go to your calculator, we want to look at the definition. So did you write that other part down up here that I had? This?
Yeah.
Some of you didn't yet. You're still playing with your sweat. Get your pencil out and write it down so we don't have to wait for you. Okay?
Okay.
So this part right here. So when you look at that next part down in your notes, if we are looking at the vocabulary, Sam, would you read what it says for our vocabulary? Yep, that y-intercept part. Yep, right here.
The y-intercept of the graph is the point where the line crosses the y-axis. The y-intercept can be anywhere on the plane. The y-intercept is usually represented by the variable b.
So when we look for the y-intercept, it has to be on this y line. That is the key thing. So in this case, it says that's going to always be our b. But sometimes we are going to write that as our 0, comma, b. Why 0b? Because this point right here is 0, comma, 1. So it has to be on the y, and every point on the y, if I'm looking at this point, this is 0, 4. This point down here would be located at maybe 0, negative 1.5, right? If it's halfway in between these two. So this point, so every time we talk about a number on the y-intercept, on that y-axis, it is always 0 and the number. Because the y-intercept, for a proportional relationship, we said anytime it's proportional, has to go through 0, 0. So what I'd like you to do is right next to each of these, please tell me your y-intercept. So the y-intercept on this first graph, if I'm looking at it, is located at what point? 0, 1. 0, negative 1. 0, 1 is right here, right? Do you agree this is 0, 1 up here? This point down here is 0, negative 1. So if I was looking for my b value or my y-intercept, I could write it like this. Or you could tell me b equals negative 1. I would take either answer. So please write now for that second one, right? Located where? 0, 2. And Kendall, if I wanted to write it just b equals, we would say b equals 2. Now, I do want you to take a look at this. If I would have asked you for the movement, the slope, what would our slope be of this line? What would my movement be? So you still should have this page open. If I was looking for the movement, what would my m be? My rise over run as I look at that. Rajad, what would my rise be from this point to this point? 1. And if I was looking at that, Cameron, what would be my run? It would be 2. So if I was looking at this one, everyone on their notes to put m is 1 over 2, rise over run, right, for this one. What would our slope be here with these 2 points? M would equal what as I look at that, Levi? What would my rise over run be here? I go from this point and I go down.
rise would be -2.
-2.
And the run would be 1.
And the run would be a positive one. And does it matter if I have 2 over -1 or -2 over 1? These two are the same, right? So we kind of talked about that Friday. And the reason being is that as we are working now, is again, on that Desmos calculator, it says, in this lesson we're going to investigate what happens to a number when we are looking at y equals mx. But now we are going to use it to fill in the plus b. So, first off, it says, what is the number of our unit rate? What is our m in y equals mx? What would we say as we are looking at this one, Jordan? What is our m? Careful. The m is the coefficient of x. So I could write this as y equals 1x plus 3. What is my m? Unit rate should be 1 or 1 over 1. It is never a variable x. Okay? When I look at the second equation, what is my slope, my unit rate? Should be, Matt? This is without using our calculators, right, or our computers. 1, again, 1, and we could write it as 1 over 1. Where is the m? M is always in front of the what? No, not in front of the equation, in front of the what? In front of what letter? Right in front of the x. It's the coefficient of our x, right? So here, the slope was 1. Here, the slope was 1. It says, what number is added? So if I'm looking at what was added, I would say, what, Joe? What was added?
3.
Plus 3. If I'm looking at the second one of what was added, Ashley, I'd say plus what? Plus -2. So, again, when we draw these on our computer, we want to go to graphing it, and we are looking at graphing it with the Desmos, as you were looking at that. So the first equation I want you to put in, as you are looking at that, we're just going to put y equals 1x. Okay? Next equation in number 2 is where we are going to put the same one that was on our worksheet. Y equals 1x plus 3. Do you have to put the 1 in there? No, you could just put y equals x plus 3. I need you to draw this one right now on the graph. So what we are going to take a look at is here. It says draw a sketch of the graph. So we are going to our blue one is the one I want you to drive. That means I need to go up 3, right? I can tell that point. And then when you look at your graph, right, they give us the point here, 0, 3. This one is at, if I'm going up, what do I notice about every x and every y? I go up 1 and how far over? Up 1 and over 1. Up 1 over 1. That slope that we had. So when you draw yours, I want it drawn accurately. I'm going to come around and hand out to you rulers so that you can draw this accurately. So we're connecting these with a line. Please make sure you put arrows on your line. The last question here says, the line crosses the y-axis at what point? We're talking about this point. That is at 0, 3. The next one down should be at, write that in. The next one, if we were looking at, should be at 0, -2. Do you agree that when we said originally that our slope was 1, our unit rate is up 1 and over 1 each time. So when we are looking at this movement, this is where the 1 comes from. You went up 1, you went over 1, right? Here's our movement 2. You could go up 2 and over 2 if you are looking at that. That gives you a movement. The M moves by 1, right? Up 1 and over 1. The next page down in your notes asks you to change some different things. So this one is asking us what our slopes are. Where is the slope when we are looking at our equation y equals mx plus b? One of them, Levi, and the first one would be the number in front of x, so I would write down 2. So when I go to graph these, you're going to do the next 2 together, right? So we are going to go back. We're going to keep this first one as y equals x. I always want you to keep that one. And if you like putting in 1x, keep it that way. But now our second one is the equation that is here, y equals 2x plus negative 3. So when we look at that one, we are going to put in y equals 2x plus negative 3. Now when you put plus negative 3, plus, and then we put negative 3, right? So we should be able to see those graphs. So each one, I want you to put in the next 2 graphs as you are looking at these 2. So you're going to look at these 2 together, then we'll look at these 2 together. So the first column was, what is our unit rate? The second column, what was added? This one would be plus negative 3. Draw the graph. Tell me where it was on the y-axis. Okay, so I'm going to give you a minute. Number here will be the same as the number back here. Some of you didn't have that. Change it and write down the right number. 0, negative 3, then the slope, this is our 2 over 1. So from your graphing calculator, you should have seen 2 over 1, 2 over 1. I am going to look that you take your straight edge and you draw this accurately. This next one, when I took a look at it, we should have seen our slope again was 2. That's our rise over our run. As I looked at that, Nolan, what did we have for what was added? Plus 4. That means I need to see on your graph going up 1, 2, 3, 4. I can't really go up 2 and over 1 kind of on this graph, so I'm going to go down 2 and back 1. And if I'm looking at yours on your computer screen, I want to see this next graph if we were looking at it. So I want to see when I look at yours, y equal 2x and we should have had plus 4. Now, the one that I don't need to see is we're going to take away that one. What do you know about those 2 lines? They both have the same slope, and they are what kind of lines would you say? When we see both those 2 together. What is that when 2 lines are right next to each other and they're kind of right like that going up and down? Yeah. We would say they are parallel lines. Thank you, Ryan. And what do you notice about these equations? They have the same what? What's the same in them? The m, the slope, the movement. So when you have the same slope, you're going to have parallel lines. Every time you have the same slope, you're going to have parallel lines. So we now want to turn these 2 off. So make sure you turn those 2 off. And if you didn't already, make sure you put in the next 2 equations. Y equals negative 3x plus negative 2 and y equals negative 3x. And if you didn't answer those questions, please make sure you do that right now. So we are looking at y equals negative 3x plus a negative 2. Could we just write minus 2? Now look at this one. If I put it in like this, y equals y minus, does it work? So first thing I have to go back and I need to make sure I have an equal, right? But when I look at that, I want you to look at that. Y equals negative 3 minus 2. What kind of a line should that be? It's horizontal. What do I need in this equation? I need an x. And so if you don't put an x in, you're always going to get a horizontal line. That changes it, right? The last equation should have been y equaled negative 3x. Please make sure you draw both of these in your workbook, in your notes. So again, you have two parallel lines. The first one started at 0. The second one was at 0, 0. The first one was down at 0, negative 2. What is my slope as I'm looking at the slope, Caitlin? Our slope in y equals negative 3x plus negative 2? Negative 3. And I'm going to write it as a fraction because I want to think of it as my rise over my run. Okay? Dan, what did I see was the y, or the plus number? Negative 2. So I started my graph down here at negative 2. Okay? 0, negative 2. On your paper, you want it to be very accurate. You were then going down 3 and over 1, or going up 3 and back 1. So that, Rowan, when I looked at this, where was my y-intercept? At 0 what? 0, negative 2. The one above should have been 0, 4, right? That was this point here. Here we are talking about this point. As I look at that last one, what am I looking at as I take a look at that, Olivia? Slope was negative 3. And again, when you think of slope being negative, that's telling us it's going down, right? When we think of that face, that was the line going down. Whereas positive slope should always be going up to the right. Both of these went up. This one had to go through 0, 0. So the added number, there's nothing there. That means it's 0, right? Plus 0. It went through the point 0, 0 when you looked at that graph, right? When we were looking at this blue line, there was nothing plus back here. That plus number is a 0. So when you graph that, we should have had 0, 0. We still have to have that same slope of negative 3 over 1. So up 3 and over 1. And again, when you are doing these, one of the nice things about this, working with this calculator, is that you can turn these off. So we have these two being parallel. We would now have those two being parallel, and you can turn them on and off, and you don't necessarily have to retype everything. So we now want to take a look at that next page in your notes. And you kind of need to keep going back and forth to these pages as we are looking at this. And it says, well, when you add a positive value to b, was the y-intercept above or below the y-axis? So when we added 3, when we added 4, was it above or below our y-axis? It should have been above. Do you agree if we look back at our equations? So when you look at the graph, when I turn all of these on, and I look at this one, which was plus 4, and I look at if it's above, if I have a plus number, it's going to be above the y-axis. It now says, well, if I add a negative b, where is that above or below our x-axis? And it should be below. And when we talk about the x-axis, this is our x-axis, right? This line right here is our x-axis. When you move along that line, that is your x-axis, okay? So as we take a look, it says, well, what is the y-intercept in each of these below? So the first one, as I take a look, Jordan, that first one, what am I adding? It should be, my y-intercept should be 1. So when I take a look at that first one, my answer would be 1. I could also write it as an ordered pair 0, 1. The next one, as I look at, Grace, would be what? Negative 4. Or I could write it as an ordered pair 0, negative 4. Okay. As I am looking, Rajad, that last one should be, say it one more time, negative 8, or I would write it as 0, negative 8. Please write it both ways for me when I'm asking you for the y-intercept. Put it first as an ordered pair, and a number, or a number and an ordered pair. So it says, look at the first two graphs. What is the same in them? So, again, looking at your first two graphs, right? If it helps you to turn off the second two, what is the same in these? Should be the what as I look at that. What is that called, Dan? They have what is the same in those two equations?
The 2x.
The what?
The 2x.
Okay, so that 2 is the same in both of them. So when we are taking a look at this, what is the same? That's called our slope, right? Same slope, and I agree, we might want to put equals 2. It says in the middle two, what is the same on them? So again, we are looking at those middle two graphs as we look at that. And as we look at those middle two graphs, we are looking at the y equal, oh, these are our middle two, which was the 2. The first one was x, right? I didn't have that one. It was x plus 3, if we put in the first one. And the next one right below that was y equaled x plus negative 2. So again, if we have all of our graphs in there, so 1x plus negative 2 or minus 2. So that when we are looking at those graphs, right, if I wanted to look at the first one only and the second one, this is where my slopes would have both been 1, right? Parallel lines. The second two, what was the same in the second two? They both had slopes of 2, correct? So this was a slope of 1. The second two graphs had slopes of 2. It says if you look at the last two graphs, what's the same about them? Again, we have our same slope, but this time the slope was, so the first one it was 1, second one it was 2, and the third one was negative 3. Graphs that have the same slopes are, what did we say? Parallel to each other. It says if you change the b value, does it affect the slope? So does it ever, the number that I'm adding, when I add and I look at plus negative 3 and plus 4, does that ever change the slope of the line? What does it change? It changes where we put the, what is that called? Special vocab today. What does that change? It changes our y-intercept. It doesn't affect the steepness of the graph. What we want to take about what it does change, it changes the location. So when we change the b value, it does not affect the steepness of our graph at all. The m affects, right? The b value is where it crosses the y line. That's the only thing that the b value changes, where it crosses the y-axis. So when we change the m, it does not affect the y-intercept. The m doesn't affect the location of the y-intercept. What does it affect? It affects how we move. So the m is how you move. The m is the rise over the run. The other thing I would like you to put right below this is that m value. M is the one that affects the positive and negative. And if we are talking about that, this is our undefined, right, with the U below that. And then our mouth is the 0. So when I put in the y equal, okay, when I put in the y equal negative 3 minus 2, that had a slope of 0 because there was no x. So this is the equation when we write this equation where you have y equals only a number. Y equals negative 2. And again, as you're looking at your graph, you can put those in and take a look on the graphing calculator to look at those. So we're still going to use your graphing calculator. It says describe and compare the graphs of y equals 4x minus 1 and y equals 4x plus 3. Using your graphing calculator if you have trouble visualizing. What do we know about those? What's the same in those two equations? Yeah. They both have 4x. So they both have a slope of just 4. Slope is 4, no x, right? And what are their y-intercepts? First y-intercept is If we are looking at it, first one is -1 and +3. So please pull up your graphing calculator and you can probably eliminate some of these and just put that equation. The y equals 4x. So put those two equations, y equals 4x minus 1 and y equals 4x plus 3. Put those in on your calculator. Questions in our notes, you can see those, visualizing those two, and we would now say that when we look at those, the lines are parallel, different y-intercepts. And the reason they are parallel is they have the same slope, which was 4. They are parallel lines. The first one is below because they have different y-intercepts, -1 and 3. It says write an equation for a line horizontal y-intercept 3. So go to your graphing calculator. Horizontal y-intercept 3. What is my equation going to be? Y equals what kind of a number that's going to meet this equation? Has to be horizontal. So what do we know the slope is? 0. Can you put in 0x plus 3? Yes. Could you just put y equals 3? We cannot have x plus 3. X would be 1. So I want either one of those two for number 2 up there. The next one says slope of 4, y-intercept -7. What does the equation look like? Slope of 4. Y equals 4x plus -7. Could you have y equals 4x minus 7? Okay. So put in those next two. And again, if you want to try that on the graphing calculator, you can. We don't need to do that right now. This last one, though, we want to write an equation that is parallel to this one, which means they have to have the same what? Same slope, and a y-intercept now of -5. Here the y-intercept was 1. My equation should be y equals -3x plus what? Plus not 5, but -5. And could you check that on your graphing calculator? Yes. You could go to putting in your equation y equals -3x, right? So we could put in y equals -3x if we were looking at that one, plus 1. And if I have to get it equally, no, we don't want that much in there, so we're going to take that out. That's why I couldn't graph it. And if we graph that second one, right, when I graphed the second one, I needed it to go through, it said -5. So y equals -3x. And then we are putting in plus 5. So when we look at those, or it was plus a -5, right? -5. So you can see how that's kind of moving your graph in that it moves the starting point, but they are still parallel lines. So when you're finishing this last one, we want to write one that is a line that's parallel, but it's going to be between these two. What do I need the plus number to be? Y equals 2x plus what kind of a number? 3.5. Could it be 3.2? Could be 3.7. Has to be between. So when I look at your homework, your notes on this one, if you had any number, 3.1, 3.2, 3.7, right? As long as it is between 3 and 4. Your homework. So for a lot of you, we just talked about at the beginning of the class, some of you have 7, you have 8, and on tonight you have 9 to do. You should make sure this is 2 pages that you are getting done. When you take a look at question number 1, as you look at question number 1, would someone please read for me before I pick any? Go. Yep. Just a little louder. Just past, right, reading the story.
Last summer, Tony and Jason went to the library for another fair. The fair has a you arrive between 11 a.m. and 1 p.m., your admission is free. If you arrive after that time, admission is $8. Individual ride tickets cost $2 each. Tony went to the fair at 12 o'clock p.m. and he went on 12 rides. Jason went to the fair at 1:30 p.m. and he also went on 12 rides.
So you need to set this up, and it says, so we know what time they started, and it says make a table that represents the number of rides. That's going to be my X, and the cost Y. So please make these two XY tables. Now the reason I'm going to go across is that I have more room. This is my X, this is my Y. So we need to go for 0 rides, 1, 2, what's the most rides they're going on? 12. So you should make your table so that you can get 3, 4, 5, all the way up to 12, correct? For each person, you need to go 1, 2, 3, all the way up to 12 rides. Tony entered at 12 o'clock. Did he have to pay an entrance fee? No. So at 0 rides, it cost him $0. How about Jason? What did he pay before he entered? Make this on your table, right there. What did Jason have to pay? $8. So make sure you finish D